Right, we're going to be talking about largest contentful paint right after we've gotten that fantastic overview from Annie on cumulative layout shift. We got this going on now. So, all right, so yeah, moving on. My name is Paul. I work on Lighthouse, PageSpeed Insights. I sometimes hack on Chrome, usually the dev tools. It's kind of my jam, web performance. So, all right, largest contentful paint. Here's our basic overview. We're going to answer a few questions. Why do we need a new metric? What is largest contentful paint? What are some of the peculiarities of it, some of the details about it? And then how do you measure it? So kicking off, why do we need a new metric? I think that's an important question to answer because, well, I feel like this, there's a feeling going around and it's metric fatigue. And metric fatigue is bad. It is uncomfortable. There's just a lot of acronyms. You got to keep track of them. It's annoying. And believe me, when speaking as someone who contributes to introducing new metrics, I can tell you that everyone who also contributes to that is very aware, and we're not trying to tire you all out with new acronyms, but we do add metrics for a reason, and that's there's always an opportunity to better quantify the user experience, and we want to do a better job there. So a few talks have covered these phases that we consider, especially in load. And one way that I like to look at these phases is in kind of the timeline of a page load. So at the beginning, is it happening? Am I in the right place? Is this going on? Is it starting to be useful? And then like, is it now pretty much finishing up and ready to be used? So I also think that these user moments also map pretty well to the general phases of load. We have the early load when things are just starting off. We have the mid load when things are coming in, and then late load when everything's settling down. And what we want really, because load takes a while and there's no one point in time that really matters, we want coverage for all of these things. We want metric coverage. And so this is kind of the 2019 perspective of metrics. In the early load, we have first contentful paint. In the late load is time to interactive. Let me take a sip of water. And then in the middle here, we have speed index and first meaningful paint. Speed index is a fantastic metric, but one of the challenges is that it relies on screenshots and then analyzing those screenshots, looking at that pixel data. It's a very computationally expensive metric to compute. There's not really a way around that, although many approaches have been attempted. And so this is a lab-only metric, and just will not ever really be a field metric. And one thing that we want out of metrics is that it is measurable in both locations. So this is just not going to work for us. That leaves FMP covering the mid-load. But FMP has some issues. And actually, to cover that, I could just rewind the clock to 2 years ago at this exact same conference, Perf Matters. I was giving a talk on performance metrics. What do you know? And so first meaningful paint. Well, it's when the meaningful content is painted. And that's easy enough. How is it implemented? A little bit more tricky. It relies on a concept of layout objects, which is kind of like, DOM elements that are layouted. They have layout. So layout objects, and then basically we're counting the number of layout objects that are added into the layout tree. Implementation wise, yeah, it's a little funky, but it kind of did good. So the definition is this plus a handful of other kind of heuristics, handling web fonts and things like that. It works well, but it has some problems. And over the last several years, the Chrome Speed Metrics team has kind of learned some things about the strengths of good metrics, the weaknesses of poor metrics, and put a lot of these learnings into this great document. This document is actually in the Chromium source tree, but you can find it on your own. And it's properties that contribute to a good metric. And I'm going to cover them now. So we got 9 properties, and I'm just going to touch on each of these. First up, representative. The metric is representative of the user's experience, that it measures something that is meaningful to the user. Whereas, DOM content loaded, what does that represent to the user? Usually not much. Accurate means, well, it's just the metric does a good job at actually hitting that moment in time. Stable means it doesn't change a whole lot from run to run. This is really important to make sure that metrics are reproducible, that you're doing it repeatedly and it's not changing all over the place. It'll change a little, but not all over the place. Interpretable is just like, we can talk about it. It doesn't take a long time to explain it. You say first meaningful paint, people are like, okay, yeah, I kind of get it. Simple, on the other hand, though, is more about like the implementation is straightforward and simple, so that when we're trying to get cross-browser support, it's simple and straightforward to get implementations aligned. Elastic is kind of interesting. An elastic metric is resilient to small changes in the environment. So say, for instance, TTI is a metric that one of the signals is around long tasks. And a long task is anything that's 50 milliseconds or longer, of course. And if there's one long task that just pops up at the end of your load, then all of a sudden your TTI is extended way out there. And if that task had just been 49 milliseconds, wouldn't have happened. But now that it's 50 milliseconds or 51 milliseconds, now TTI can move considerably. And so that's kind of a challenge. If, say, for instance, so you want to make sure that metrics are not too sensitive to these small changes. Real time is mostly that it can be computed real time, whereas speed index requires kind of post processing. Real time is also what it kind of enables the metric to be implemented in a RUM scenario. Orthogonal just means that the metric doesn't measure things that other metrics already capture. So there's just not overlap with other things. And then correlates is just that there is the lab version of the metric correlates with the field data of that metric, and that there is some consistency between those two. So that's the good components of a metric. And these are certainly things to keep in mind as far as creating your own kind of domain specific metrics that are specific to your app and your experience and your users. Okay, so applying these to first meaningful paint, is it interpretable? Yeah, like it's easy to explain to people, and it can be computed in real time. But then it's not elastic, because it relied on this idea of layout objects, and unfortunately, small rendering differences can tweak that. And so I know that the first meaningful paint on my own website was completely bimodal. It was either at like 1.6 seconds or is it 2.9, and one or the other, and it just like 50% chance of either of those and nothing else. Also, first meaningful paint is not simple because it has this layout object definition. It couldn't progress in the working groups, the WebPerf working group, and so that meant that it could never be a WebPerf API and be measured in a RUM scenario. So unfortunately, I have to tell you, first meaningful paint, yeah. And the raven, never flitting, still is sitting, still is sitting on the pallid first meaningful paint just above my chamber door. And my soul from out that shadow that lies floating on the floor shall be lifted nevermore. Okay, so bringing that back. Right, so we're back here, and FMP is out. So what's in? Well, the Chrome Speed Metrics team kind of evaluated a lot of candidates for metrics, a lot of things that we could consider that try and track this. And there's a good amount of possibilities. And actually, around this time, there were some other folks investigating the exact same thing, even a little bit earlier. So back to my talk in 2018, I talked about hero rendering times. And in fact, I'm just gonna we're just gonna recreate it. Okay, so 2018, yeah, cool. Hey, so next metric we're gonna cover, hero rendering times. This is a new metric from Speed Curve that introduced it a little bit ago. And I've been thinking about it, talking about it, and it's like actually refers to multiple times, but I feel like it should be one time. And so I went down at the Perf Matters conference party just last night, talked to Steve Souders, true story, and said, Steve, maybe I feel like we could simplify this. What if it just is one time and we give that a name? Maybe we just name it a new thing like Last Painted Hero. And he's like, And then I'm like, but maybe I could sell you on it. Maybe if you guys are born in the 80s, you might appreciate, yeah, Last Painted Hero. Well, Steve was impressed. He signed. He's on board. Last Painted Hero, gets the Last Painted critical content, and anyways, turns out Last Painted Hero is pretty much identical to Largest Contentful Paint, with just like a few small differences. It was really kind of cool. We basically had two independent efforts investigating this, and they both converged on the same stuff. So, all right. So the Chrome Speed Metrics team took all these candidates, implemented all of them in Chrome, and then collected a bunch of traces on thousands of websites, traces and film strips, built an entire tool that would plot the film strips, also a visual representation of paint triangles, rectangles, and then marking where each of these metrics lines up. This then allows you to review it as a human and decide, okay, well, is this a meaningful point in time when we had the largest image paint or the last text paint? Are these meaningful? So after reviewing hundreds of these film strips manually, there was a winner, and it was this one. And this is the largest contentful paint. All right. So largest contentful paint is, well, it's not too bad. It's pretty straightforward. Taking these two examples, our largest contentful paint in the first film strip is the Instagram logo, and the first time that it was painted was here, and so that's our point in time. On this search results page, it started out as this little text layer page, and then it was the paragraph right here. And even though images came in afterwards, the images were not bigger, and so this remained the largest, and it was painted here. So this is our largest contentful paint. That's pretty straightforward enough. The simplest definition that's accurate is the render time of the largest content element visible in the viewport. Largest content element is really just the largest contentful element. Well, all the same thing. How do you define a content element or contentful elements? Well, you got a few options. You have foreground images. So this is an image element or the image element, because clearly we have to distinguish image from image. Right, image, the ones inside SVG. Right. So we know what this is. Contentful background images. Interesting, right? What is a contentful background? Here's an example. A stylized drop cap. This is contentful, and to do this, to pull out this technique, you use a background image in order to make sure the accessibility and the U is still text and all that stuff. Right. Then we have video elements, but only video elements with poster images. But that's not really a big qualification, because like 95% of video elements have poster images. So, yeah. And then text elements, basically any block level element that contains text and text nodes, that is a content element. Okay, so then we need to talk about what's largest. So how is the size determined? Well, starts off pretty basic, width versus height, pretty easy. But then margin, padding, and border are not considered part of the size. And if you want a real definition of size, you can look at the intersection observer spec and the intersection rect, I think, defines all this stuff. So anyways, but there's a few more kind of tricky situations that we need to handle as far as size. All right, like these. Okay, first one, a downsized image. We have like a high-res image that we actually are forcing to be displayed smaller on the page. Happens a lot, right? Sometimes 5,000 by 5,000 images shrunk down to be thumbnails. Kills me. Anyways, okay, so we got this situation. And here, the size that's used is the smaller display size. Then the upsized image, we have low res, and then we blow it up, and it's fuzzy, maybe a little bit, maybe a lot. In this situation, we use the smaller size, so that's kind of the rule here. And then anything that's partial viewport, whether it's out of the viewport or it's clipped by overflow, it will only be the area of the element that is visible in the viewport, not clipped by overflow. All right. So that covers largest contentful element, covers the viewport. We have the render time. A few more technical details going on here. So stay with me. For images, we care about the render time. So the time that we measure is the time of the paint that immediately follows the image's on load, when that image is fully loaded, which, if you're thinking about one thing, think about the same thing I am. Yes, it's progressive images. So that does mean that progressive images will not be getting a render time of like the first pass, the first scan of the progressive image. It will be when the progressive image is completely downloaded. So even though progressive images do have benefits to users as far as the user experience, the render time aspect of this doesn't really catch that right now. And to be honest, it's very tricky to. Personally, the general pattern of showing a low resolution kind of stand-in placeholder effect, that I think is a really smart move, especially when the image sizes are quite big. So I think that's a great general pattern to follow, but this is just something to keep in mind. So that's images, and it's actually same origin images is this, because cross-origin images is tricky. This has a lot to do with everything that we learned from Yoav in his talk earlier. Privacy concerns are really tricky, especially when dealing with cross-origin items. And getting accurate times is a really tricky problem here. So basically, if a cross-origin image is served with the timing allow origin header, that header is just saying whatever web page consumes this can have access to all of the specific timings, then that paint time will remain accurate. But otherwise, the best time that you can get is the onload time of that image. So the difference between the onload time and the paint time, like we're talking about somewhere between 5 and 50 milliseconds-ish normally. So it's not a huge difference, but accuracy is great. And so the better accurate, that's certainly what we want. All right, so that covers images. Video elements, again, like I said, they have to have a poster image. And if it's a poster image, it's an image. And so it just follows the exact same rules that are defined right here. So that's pretty straightforward. And for text, it's just the paint time, the first paint of the text at its earliest font. And so that's a key thing to kind of note is even if the web font upgrades the text to its new font later, render time points to the beginning one. But then also if you're in the font block mode where the text is invisible, then render time won't, like, you didn't render it yet. So we wait until the glyphs are visible to the user in whatever font they are. All right, render time, good. Moving on. LCP's peculiarities. Some of the interesting things about how it works, right? So one challenge is that measuring the last and of anything is a really hard problem, especially just in the field. Especially, yeah, because when is it the last? First contentful paint, for instance, well, it's the very first paint. As soon as you have a paint that is contentful, well, that's it. But LCP is basically last largest contentful paint. And finding out when the end condition is tricky, right? Like, all right, so in this load, well, the LCP was probably one of these images, or maybe it was this block of text, depending on the size. Here, it was definitely this image. And then finally, when this image loaded, well, the LCP switched from this to this. But also, like, who's to say that, like, the page is about to load an ad that takes over the entire page, and then the cumulative layout shift goes crazy, but then the ad is huge, and then the LCP points to that thing. Certainly possible. So here's kind of two real examples. At first, our largest contentful paint candidate is this little, is the paint of this thing, and then it changes to this headline, and then finally there's a hero image that's a bit bigger than the headline, and so this paint wins. On TechCrunch, which has the worst layout shift of, I still can't believe it. On desktop and mobile, it does this. It loads in this headline, and then all this shifts down to add in this. So anyways, it moves. It's here. It's here. Then it's this headline. Then the headline moves, and then it's the hero image. So it's just moving around, right? And if we had stopped caring about, if we had stopped listening, we would be looking at the wrong point, right? So it's tricky. How do we know when to stop evaluating? What is our end condition? The first thing is that we need to consider input. Basically, input invalidates all of the LCP candidates that happen after it. If the user ends up tapping, scrolling, anything like that, then the browser will just stop looking for another large contentful paint candidate. And the reason why is basically, if it didn't, then LCP would just be measuring the time to any user input that inserted a largest element. Like, user did something, and then the web page responded and added content. But then we're not measuring the largest contentful paint during the load. It's just the last time that the user interacted and the page responded in a big way to that interaction. And that's not what we're attempting to measure here. So that's why anytime after input, we stop basically considering any more candidates. So sorry for the TTUI title, which is honestly really catchy. Kind of sad to see it go. So LCP is considered final when one of these two things happen. There's user input, which includes scrolling, or the page unloads, which is basically just like the user's navigating away. This matters a lot when you're measuring LCP in the field, but in the lab, there's no user input, and you decide, or your tools like Lighthouse decides when it stops listening to the page. And there's a good amount of heuristics built in to choose a really good point for that. So in the lab, you're kind of good here. In the field, it gets a bit tricky. Another tricky peculiarity is around removed elements. So consider this this film strip. We're like loading, we got a few things, and then we have this big splash screen, which is like, hey, be right there. And then finally the content loads in. And when that does, this splash screen is removed from the DOM. Is this screen like significant and meaningful to the user and like the largest content? Excuse me. Not really, no. So largest contentful paint right now considers anything that was removed to basically like it was ephemeral. It's not meaningful to the user. We basically discard it. So you can have a candidate, largest contentful paint candidate for that element, but as soon as that element has been removed, the browser will immediately find a new candidate and be like, well, we have to because that one's gone and dead to us. I do want to point out that this behavior makes a lot of sense for this sort of scenario, but there are scenarios where it's a little trickier. A common pattern is a product carousel, just a normal kind of image carousel thing, right? A lot of the ways that those are implemented is that when an item in the carousel rotates out of view, it's removed from the DOM, which seems good, kind of makes sense. Unfortunately, the way that LCP will handle that is that it will ignore that thing going out, but then the new thing comes into the carousel, and then so it creates a new candidate. And this ends up basically meaning that LCP just continually marks the newest addition to the carousel, which is basically a measure of how long the page is open, which isn't great. So the team working on the Chrome Speed Metrics team working on largest contentful paint is looking at this, trying to figure out how we can best handle this to make sure that the metric handles these situations correctly. All right, how do we measure this? Well, there's a few different options. So we can measure it in the lab and in the field. We'll talk about the lab first. This is great. So as of like 6 months ago, this has been around for a bit. You can open up a performance panel, get a trace, and in this timings row right here, you'll see first paint, first contentful, first meaningful, DOM content loaded way out here, and LCP. And you can click on this little rectangle, and you'll get this details in the summary. Here we have the size. This is just width versus height, the timestamp where we are in the trace, and then the related node. And what's really great is that if you hover on this related node, or even if you hover on this little chip right here, you'll just get the kind of typical DevTools inspection blue hover overlay that will point out it was, this image, not anything else. So it's really nice to just get that like feedback, not only when it happened, but like what is the contentful element, and you can just receive it right here. So that's in DevTools. You can also look at this in Lighthouse with the Lighthouse 6.0 beta, which you can install with NPM. You'll see largest contentful paint. And we are actually just about to land a new feature that exposes the exact same element reference. And if you're using Lighthouse inside of DevTools, you'll get the same thing where we'll tell you this largest contentful paint 9 seconds, and we'll show you what element it is. And if you're not inside DevTools, we'll tell you everything that we can about the node so that you get an idea of exactly what element you're dealing with. Then moving to the field, the Chrome User Experience Report it includes largest contentful paint as of several months ago. So Annie showed off an approach like this before, basic query, which just gets for example.com all the data. And so I'm just plotting all of the histogram bins and the average density, so we can get a sense of how your specific website does on this metric. You can also, there's in this link, there's also some really useful kind of recipes for working with BigQuery that will allow you to not only capture it for a certain month, but also see how it changes over time. It's really great. And then WebPerf APIs is the other way that we can measure in the field, right? So we will set up a performance observer. We should be pretty familiar with this at this point. We're going to, on the observer, we're going to observe the largest contentful paint type.
And inside it, so we're getting the last entry, and then we just print out the start time. And that's basically all we need to do. Of course, this callback can fire multiple times. So if it does, we just care about the last one that happened. I did want to point out, this is a brand new Chrome extension that Dion Almer released just yesterday, I think, 2 days ago. It's great, tiny little Chrome extension, but what it does is it adds up in your browser actions bar. It'll say, okay, this page actually got a LCP of 1.2 seconds, and the little color chip behind it will change color based on if that's good or adequate or poor, depending on what thresholds that hits. So that's a really kind of cool way just to have it like get the feedback of what every single page's LCP is, every page that you load. So I've been loving this extension. It just uses the exact same WebPerf API that we were looking at right here. So check that out. I do want to point out something about when we're looking at these WebPerf APIs. Probably heard of the paint timing API, and largest contentful paint is not part of it. So paint timing API is type paint. And when you do type paint, you'll get entries for first paint and first contentful paint. Largest contentful paint, 1 second, was there's a few reasons why it doesn't make sense to basically include in this other type, but it's actually quite good because largest contentful paint, when you receive it, I'm fortunately here, I'm just logging just the start time, but you get a reference to what element it is, what actual DOM element is the contentful element. So I recommend you check that out. But anyways, these are two different APIs requiring you to observe different types. Both are good. Just wanted to call that out. The other thing I wanted to call out is this buffered flag, if you spotted that. What is that all about? It hasn't been covered too much. Annie did mention it. I just wanted to go over it again because it's really valuable. The cool thing is when performance observers came out, they didn't have this, but as of about a year and a half ago, they do. The browser is already keeping track of all these things before you set up the observer, which is really cool. So when you say buffered, you're just saying, I would like the observer to let me know about everything that happened before I called observe. And that just means like the script where you are running this observer and setting it up can be loaded asynchronously. You do not need to put it in the head of the document or anything like that. So this is fantastic for your own web performance. And one thing is that if you're using this, you have to use type. Most of the performance observer code that you're going to see out there, like 90% of the code that you see on the web, says entry types, and it's an array. So it'd be like an array of largest contentful paint and resource. So the entry types array is fine, but it doesn't work with buffered. And if you try it, the console will actually give you a warning. So you're not totally in the dark there. But just want to call that out. It's kind of the new pattern. It's buffered and a single type. So if you want to listen to multiple types, just set up multiple observers. That's about it. All right. And what if LCP doesn't catch the thing that you really want to measure? Well, luckily, we got a nice little escape hatch. Element timing is your great solution for this. So element timing is available in all Chromium-based browsers and has been for quite a while, actually. You just apply an element timing attribute to the element, give it a little name, just a unique identifier of some sort. Then you can set a performance observer listening to type element. And then when you look through the entries, the entry identifier will be this exact guy, and you'll see the start time. And the rules for kind of the render time here are the exact same thing as what I mentioned before, as far as images and the cross-origin images and text. It's all
built on the same stuff. So that's it. There's a nice small little demo here at this link. I'm not going to open it up right now, but it's just not a lot of people have experiments with element timing API. Here's a good little demo, which just shows you things. One thing that I did is actually used DevTools local overrides to change the second image in this demo page and pull it from my domain. And the cool thing is that you can actually see, probably in this text, quite small, but the first one took so much to render. This one took 2.5 seconds to load. And this is actually because it's a cross origin image that doesn't have that header. And so it knows it's the onload time and not the rendering paint time. So yeah, so anyways, element timing API works for images, same origin, cross origin, videos with poster images, and text, all the same stuff. Cool. So element timing API are great for kind of implementing your own metrics that are custom to your users and your domain. And that wraps things up for me. Large Contentful Paint, it's good stuff. Effective at finding this mid-load. Really good at. I encourage you to track it. You can investigate things in your lab, debug it, find out what element it is, find out and look into, can you move it earlier? A lot of times following the opportunities in the Lighthouse report are going to help you reduce your LCP. Definitely incorporate LCP into your RUM measurements. The LCP documentation page on web.dev is fantastic. So good. We'll have all the answers to everything, all your questions. Has a really great snippet if you just want to know, like, just want copy paste code to add so that you can measure this in RUM. Go there. It's this nice like 30-line snippet. It works perfectly. And I just wanted to give thanks to the big group of people who not only brought this metric to life, but also assisted in making sure that this deck didn't lie too much. So thank you all to them, and thank you everyone for your time and attention. Appreciate it.